Hey guys, and welcome back to another video on the channel. In today's video we're going to be doing the Math Methods Paper 2 Tech Active multiple choice questions in this video. So this is from the QCAA syllabus for Math Methods in Australia. So for this video here I'll be referring to a particular type of calculator. So I'll be referring to the FXC, was it G50 AU model. So that particular calculator. So that calculator is pretty special because you can put in certain integrals and do stuff straight away. So if you don't have that model, I would recommend it if you are doing this particular syllabus, because it just makes life so much easier and there's some tools in it you will be able to use. But other than that, let's get straight into this paper pretty much. So let's just go to question 1. So the limit of 12 to the power of h minus 1 over h as h approaches 0 is closest to. Okay, so in this particular question, this is why it's good to have the calculator, and I understand why this is on the calculator paper, because you're not going to be able to work this out really without a calculator or the stuff you get taught in math methods. Okay, in other syllabus you would be able to work this out theoretically using like L'Hopital's rule, but you're not taught that in this particular syllabus. So what I would do is put in a number h very close to 0. So for starters, I would put in 0.01 and then plug this into my calculator. So 0.01 minus 1 all over 0.01. And if I put that in, I get roughly 2.516. Okay. Then I'm going to write this up here just so I have a reference to it. Okay. 2.516. Okay. So at the start, I'm thinking, okay, C is looking kind of promising, but we have to see where it particularly goes. Okay. So now I'll put in a number smaller than that. So for example, I'm just going to rub this out. I would go, let's go 0.0001. So then I would plug this into my calculator and then see what this gives me. So 0.0001. And if you plug that in, it gives you about 2.48. And there's a couple decimals. And then you'll start to notice if you start putting in smaller numbers, you still stay around this number here, roughly. So what does that mean? It's none of the answers given here, but you've got to look at the wording of the question. It says closest to. So it's not going to be the exact number. It's the number that's closest to. Now, it's not closest to 3. It's closest to 2.5. So that's the answer to question 1. And that's how you would go about it in the math method syllabus. In other syllabuses, you could probably use different calculus techniques, but in this particular syllabus, you're not taught those. So this is how you would do it with the graphics calculator. Okay. If you have any questions about question 1, leave something in the comments and I'll try my best to answer them. So let's move on to question 2. So the pH of a substance is the measure of how acidic something is, and it's given by the formula pH equals negative log base 10, brackets hydrogen ions, okay? So if the pH is equal to 0.2, the concentration of the hydrogen ions, moles per liter, is closest to. Okay, so this is an application question of a log. So we know if we have an exponential like this, we can rewrite that as a logarithm. What we're doing is pretty much doing the opposite, because at the moment we know what the pH is. We want to find what this is. So what we're going to do is pretty much go backwards and rearrange this formula into an exponential. Okay. So let's just write out what we have. So we have pH equals negative log base 10 of the hydrogen ions. So rearranging that into an exponential, you're going to have the hydrogen ions is equal to 10 to the negative pH, okay? And you're told the pH is 0.2. So what you put in your calculator is 10 to the negative 0.2. And that's going to give you roughly about 0.63, which is B. And that's how you would answer question 2, okay? Alright, let's take a look at question C. So I'm just going to rub this out so I can read it. Let R be the region enclosed by the graph y equals x times e the x-axis, and the lines negative 1 and 1, okay? So, pretty much what that means is, if we just graph our function, let's go on to Desmos so you can see this in a better way. So we'll go f of x equals x e to the negative x. This is pretty much our function at the moment. Now, we have to look at the question again and ask what the region is. So R is enclosed by the x-axis and the lines x equals negative 1 and 1, okay? So what that means is, let's just put in x equals negative 1, okay? So it's between here and x equals 1, okay? And they said enclosed by the x-axis. So that means this, if we zoom in, this region here and this region here. Now, if you were to calculate this integral here, you would get a negative number, and this would be a positive number. So the integral wouldn't be the area, because some of this would cancel out with some of this. So what we can do is actually in the graphics calculator, you can put in these specific integrals. So what you would do is for your first integral, you would go from -1 to 0 to work out what that number is, and then make it positive. So from -1 to 0 of our function, which is f of x. So I can just write f of x in Desmos, and that's what the number is. So negative 0.26. So the area will be the positive version of that. And then you would work out the integral from 0 to 1. So you would put another integral. So let's just scroll down. From 0, oh, that's not it. I just got rid of it. From 0 to 1, that's 0 to 1 of f of x dx, and you get 1. Okay, so if you were to put in the integral, 1 minus this is what you would get given, but the area is going to be 1 plus times this by a negative number. So times it by -1, so the area should be about 1.26. So now we go back to the question, and we're looking for roughly 1.26. Now you can actually work this out in your calculator by putting this in the specific order. So you would write negative, the integral from -1 to 0 of x e dx, plus the integral from 0 to 1 of x e to the x dx, and this should give you 1.26. The reason why I put this negative number in front of my integral is because this would give me a negative number. So timesing it by -1 makes it positive. So that's what you put in your calculator, and Desmos demonstrates what you're actually looking for as well. Okay, so the answer is going to be B, and that's how you would answer question C. It's very hard to show you on the graphics calculator because I don't have the digital one installed. Okay, let's move down to question 4. Okay, so consider the function f of x. So log base p brackets x plus q. Now p is greater than 1 and q is between 0 and 1. So which of the following could be the graph of f of x? So what we're going to look for is particularly this thing here, okay? So q affects the horizontal translation. So q is a positive number, and it's smaller than 1. So for example, if I had log base, I don't know, let's just use p for example still, and let's go x plus a half, it's going to go a half in the negative direction because it's counterintuitive. So any function that moves to the right, so in the positive region, is not our answer. Okay? So for example, B isn't our answer straight away. But these ones here could perhaps be it. Now we need to remember what the normal log curve looks like as well. So if you just had any base, so if we had, let's say, y equals log of x, this graph will always go through 1, 0 without any translation. It doesn't matter what the base is, it will always go through that. So we've pretty much got to think, okay, if it gets moved 1 unit this way, it would go through the origin. But notice it can't be moved 1 unit because q must be less than 1. So the maximum it could be is 0.99. So it can't be a either because a goes through the origin. So that assumes q was 1. But q isn't 1. It has to be less than 1. If it had, let's say they wrote it like this, then it could probably be A, but they didn't write it like that, so it can't be including 1. So the answer isn't A either, okay? So it's between D and C. Now, the way we're going to work it out is, alright, let's start looking at our graphs down here. So we agree that's 5, so that's 4, 3, 2, and 1, and that is -1. So we can see my graph has been shifted more than 1 unit to the left. So what does that mean? Well, what are we saying? It can't be that where q is positive. Yep, Q is positive. Oh, it could be. Q is positive. No, it can't, because Q is not bigger than 1. So the reason why it can't be this is because this assumes Q is greater than 1. Okay? So it can't be D either. So the answer is C. So I didn't even look at the base. All I cared about was this bit of information here. So the reason why it's not D is because it's been shifted more than 1 unit to the left. But our bounds say it's only been shifted between 0 and 1 units. But this one's more than 1, and this one's in this one is 1, and this one is to the other way. This is the only possible answer because it's been shifted to the left, but it's been shifted less than 1 unit to the left. Does that make sense? Hopefully. If you have any questions about this one, leave something in the comments and I'll try my best to explain it a bit more, okay? But let's move on to the next question of the video, okay? So question 5. Okay, so an object moves in a straight line with the velocity given by v of t equals 40 times e to the negative t minus e to the power of negative 2t meters per second, where t is greater or equal to 0. The object is initially at the origin. So what does that mean? Well, that means x is 0 when t equals 0. Now, I actually don't like what they've done in this question here, because they've said the displacement time graph, but they've given it in y and x. So if this was a displacement time graph, this should be x and this should be t. So realistically, all these graphs should be x, t graphs, okay? Because x is a function of time. That's what they're saying here. So bad QCAA, bad QCAA. They did wrong graphs there, okay? So the displacement for the first 6 seconds. So what we can do is, alright, we can work out our actual function here. So we know v of t is 40 e to the negative t minus 40 e to the negative 2t. So all I did was expand that 40 at the front to each of them here, okay? If I integrate this, I'm going to get my function of time for position, okay? So 40 e to the minus t minus 40 e to the minus 2t dt, okay? So if I integrate each of these separately, I divide by the differential of minus t, so that's going to be minus 1, so I'll get minus 40 e to the minus t for my first bit. Then I divide by the differential of this, which is minus 2, so minus 40 divided by minus 2 is positive 20 e to the minus 2t, because your Euler term doesn't change. And then you got your plus c. Now, what did we say? We said it was originally at the origin, so when x equals 0, t equals 0. So that would be our initial condition, so when x equals 0, t equals 0. So I'm going to put 0 into here, so I'm actually going to rub this stuff out because I've actually run out of room. So if I put in 0, I'm going to have 0 equals minus 40 e to the, this will be 0, plus 20 e to the 0 plus c. E to the 0 will be 1, so we're going to have 0 equals minus 40 plus 20 plus c. So therefore, we're going to have 0 equals minus 20 plus c. So therefore, c is going to be 20. So our function is plus 20. Now you can actually put this into your calculator now and actually graph this particular function here. So let's just go on to Desmos so you guys can see it visually. So now we'll get rid of this guy. So we'll go, now we'll have to do an x and y in this case here. So f of x equals minus 40 e to the power of, oh sorry, it wasn't not working, minus x plus 20 e to the power of minus 2x plus 20. Okay, so let's zoom out and see what kind of function we have. Okay, so we've kind of got this shape here, and now we're going to go pretty much to our answers and see which one best matches this. So if we go back to the exam here, doesn't match that, doesn't match that, doesn't match that, and it matches that. So the answer is C there, okay? If you have any questions about this one here, leave something in the comments and I'll try my best to explain it, but let's move on to question 6, okay? So, question 6. Oil is leaking from a tank at a rate of r of t equals 9,000 e to the minus 0.2 t, okay, liters per hour, where t is in hours. Determine how much oil leaks from the tank to the nearest liter from t equals 0 to t equals 10, okay? Now, the most important thing in this question was this word here, rate. So this tells me how much the oil is changing with respect to time. But if you want to work how much oil has actually come out, you have to integrate this between the two bounds they've given you. So our answer is going to be the integral between our starting amount, so 0, our starting time to our ending time 10 of this function here. Okay? So if you wanted to, you could plug that straight into your calculator, or you could actually just integrate it and plug it in. But I'm just going to plug it straight into my calculator because that's what you want to do in this particular part of the exam. You want to be saving as much time as possible. So minus 0.2x, and then we go from 0 to 10, and you get roughly 38909.9122. So what they said is to the nearest liter. So what you're going to do is round it. So if I rounded that, that'd be 38910. So if we look for that, that's answer A. So that's the correct answer there. Okay. So the key word about this question here was the word rate. That means rate of change. So if you want to find the actual amount, you need to integrate a rate of change to give you like a position or amount of oil at a particular time. Okay. So that's how you'd answer question 6. Question 7. The records of a shoe manufacturer show that 10% of shoes are defective. Assuming independence, the probability of getting 2 defective shoes in a batch of 20 is blah blah blah. So now you got A, B, and C. Now, a lot of people would look at this question and think, oh, that's a proportion question. No, it's not, because of this word here, assuming independence. So what that pretty much means is binomial. So the reason why it's binomial is because if something's independent, so for example, if I were to toss a coin, if I get heads or tails the first time, it doesn't matter if I get heads or tails the second time. The probability is still going to be a half regardless of my previous outcome. So that's what it means when it says assuming independence. So straight off the back, it's binomial. Okay. So that means the probability of getting a defective shoe is 0.1. Okay, because it's 10%. And now you're asked, all right, you're getting 2 defective shoes in a batch of 20. So that is 20 choose 2 times by 0.1 to the 2 times by 0.9 to the 20 minus 2. Okay, so binomial. So what you would do is plug this into your calculator and you should get roughly 0.2852, which is B. Okay, so that's how you would answer question 7. Okay. Question 8, determine the size of angle A. Okay, so what we're going to do is adapt the cosine rule. So in your pretty much formula sheet, you get given this guy, the cosine rule. I'm writing my b's as a capital, even though it's the little b we're talking about, because they look like 6's otherwise, cos of C. I'm just going to adapt this to fit our triangle here. So this is the same as a squared, c squared plus b squared minus 2, now I'm getting confused, CB cos A, okay? Because we're looking for the angle A, so this one here. So all I've done is updated my cosine to this one here. Now I want to try and make the angle the subject, so now I'm going to rearrange this. So I'm going to minus the c squared on this side, minus the b squared on this side, and divide by minus 2cb. So I'll have a squared minus c squared minus b squared, all on minus 2cb equals cos of your angle. Then I'm going to plug in the information. So in this case here, this is my A, that is my C, and that is my B, and same down here. So what we're going to do is when we plug into our calculator, we're going to have where can I write it? I'll write it. I'm going to get rid of this now, so I can write it here. So we'll have 8.8 squared minus 11.3 squared minus 9.9 squared, all on minus 2 times 11.3 times 9.9. Plug that into your calculator, and then you're going to cos inverse this, so cos inverse this whole thing, and you should get roughly 48.5 degrees, okay? And that is A, and that's how you would answer question 8. Let's move on to question 9, okay? So question 9, the displacement of a particle in meters at a function of time in seconds is represented by this particular function. So determine the approximate acceleration of the particle at t equals 3. So what that pretty much means is you need to understand a bit of stuff about how motion works. So if we have x of t, so your displacement, if you differentiate that with respect to time, you're going to get velocity. If you differentiate that again, you're going to get acceleration. And if you would integrate, you would go backwards. So in this case here, we need to work out the second derivative. Now this is a calculator test, so what you're going to do is literally plug into your calculator your second derivative operator. So what you would do is you would go onto your calculator and go second derivative at, and then you'll put in the time, x equals 3. Now in the calculator it's going to be in terms of x, but you know that's t, and you're going to write in your function x log of x minus x. So all I did was rewrite this function in terms of x, and then if you put that in your calculator, you should get 0.33. So the correct answer is B, okay? Now it's tempting to put C, but it's positive, so the answer is B, okay? Righto, so question 10. The approximate value of x where the function changes concavity. So, changes concavity is when the second derivative is 0, roughly, okay? So, what we want to do is, alright, let's think about this. We have this function here. We could differentiate this a couple times to find its derivative, and then we could use solve-n, okay? So, we have y equals x cubed plus 6x squared plus 7x minus 2 cos of x. So if we were to differentiate this, we have dy dx gives me 3x squared plus 12x plus 7, and this is going to be plus 2 sine x, okay, because minus cos turns into sine when you differentiate it. Then we're going to differentiate this again, and we'll get 6x plus 12 plus 2 cos of x, okay. Then you're going to set this equal to 0, because that's when it changes concavity, so you have 0 equals 6x plus 12 plus 2 cos of x. Then you're going to put this into solve-n in your calculator, and you should get x is roughly minus 1.89. So answer is D. And that's the multiple choice done for the calculator paper for Math Methods 2020 QCAA. If you have any questions about any of these guys here, leave something in the comments and I'll try my best to answer them. The model of calculator that I used for this video is f of x CG50 AU. Okay. But yeah, overall, I'll see you in the next video for the short response questions.